Okay, so just got a solution here to a exponential equation, and the question would say solve for x, and we've got x is equal to 1. I just want you to pause the video and see if you can understand each step, and then I'll redo the solution. These are called exponent equations because the variables are in the exponent. Okay, so pause the video and see if you can go through and understand each step. Okay, so let's explain what we're doing. Okay, so I hope you can recognize that we can work in base 2 here. Both 4 and 8 can be expressed in base 2. And there's examples where you can't work in the same base, and I'll show you a method for solving those exponent equations. Okay, so 2 can be written as 2 squared, all to the 3x. 8 can be written as 8 cubed, all to the x plus 1. Okay, let's use our rules of powers, and a power to the power means that we can multiply the powers, so we get 6x, and then we get 3x plus 3. So a common mistake students make is that they don't multiply the two terms to get 3x plus 3. Okay, so because we are in base 2 on the right-hand side and left-hand side of the equation, we can just equate the powers. So let's do that then. Okay, so let's subtract 3x from both sides to get 3x is equal to 3, and then we can get x is equal to 1. Okay, and we can check to see if that's the correct answer. Check. Well, we've got 4 to the 3 there. 3 times 1 is 3. Then we've got 8 squared here. Well, 4 cubed is 64, and 8 squared is also 64. Okay, so let's look at another example where we cannot put each side into the same base. Okay, so let's get rid of this. Okay, so let's solve 7 to the 3x is equal to 5. Okay, there's no way we can write 7 and 5 in the same base. So we take logarithms of both sides. And you need to be familiar with logarithms to solve this problem. Okay, we can use rules of logs to take down the exponent and multiply it by the coefficient. We can divide both sides by 3 log 7, 3 log 7, and they cancel out. Then we get x is equal to log 5 all over 3 log 7. And that is approximate to 0.2757 to 4 decimal places. Okay, that's not a very elegant way, in my opinion, of solving equations, exponent equations, but in this instance we have no choice. So my favorite ones to do are where we can write the bases in the same number. Okay, so let's have a look at the straightforward one. Okay, so pause the video and see if you can solve 5x plus 2 is equal to 125 to 2x. Okay, have a go at this one, pause the video. Okay, so I hope you can recognize that we can work in base 5. So we're already in base 5 on the left hand side, so we've got x plus 2 is equal to 5 cubed all to the power of 2x. And I hope you can see that 5 cubed is 5 times 5 times 5, which is 125, hence 5 cubed. Okay, so let's use our power rules. X plus 2. We can multiply the powers here to get 5, 6x. Because we have the same base, we can equate the exponents. And if we solve that, we get 5x is equal to 2, and that gives us x is equal to 2 fifths. Okay, so I think that's quite a nice piece of maths. Let's look at 2 more examples. Let's look at one similar to this example, but just a little bit more difficult. And then we'll finish with a nice, difficult question. Okay, so pause the video and see if you can solve this. It's equal to 125 to the 2x. Okay, so I hope you recognize that we are working in base 5. Okay, so I hope you can recognize that we can write 125 as 5 cubed. So let's use the rules of indices to get 5 to the 6x. So then we can equate coefficients to get 6x. 3x is equal to negative 2, and that gives us x as 2/3. Okay, so let's finish off with a slightly more complicated question. Remember, pause the video and attempt the question yourself, and then I'll do a solution. So this time we've got 2. This dot is implied multiplication. 3 to the 2x times 1 is equal to 162. Okay, pause the video and have a go at this question. Okay, so hopefully you can recognize that we are working in base 3. Okay, so we need to do some manipulation here. So we got 2 to the 3, 2x minus 1. And we can rewrite this as 2 multiplied by 81. So let's divide both sides by 2. So that knocks out that 2. And now we are left with 3 to the 2x minus 1 is equal to 81. Okay, so hopefully you can recognize that 81 can be written as 3 to the power of 4. Why? Because 3 multiplied by 3 multiplied by 3 multiplied by 3 is 81. So let's do that then. 3 to the 2x minus 1 is equal to 3 to the 4. Okay, so because we have the same base, we can equate the exponents. And if we solve that equation, we get x is equal to 5 over 2, or 2.5. Okay, so we can check to see if we are right. I always encourage you to check, if you can, to see if your solution is right. Okay, so let's use this as an indicator. So we get 3 to the 2 multiplied by 2.5 is 5, so 3 to the 4 is indeed 81. So that indicates that we've got the right solution. Okay, I hope this helps in solving exponential equations.